What's it about? A prism, probably maybe the only word you got, maybe volume. Okay, now let's pick it apart. Rectangular prism is clearly going to be important because those are mathy words. What the heck is a rectangular prism? Well, what's a prism? Way back in grade 10. What's a prism? Versus a pyramid is the other thing. So what's the difference between a prism and a pyramid? Prism has two bases. A pyramid has one. What's a rectangular prism? Right here. In your world, it's a box. That's all a rectangular prism is. It's a box where it's got two ends and they're rectangles. Why? Why do mathematicians have to be so confusing? Well, to us, a box can have many different shapes, right? The ends don't need to be rectangulars in our world. They could be triangles. They could be trapezoids. They could be pentagons. They could be anything. In your world, a box is rectangular. So up on top of that, if you just want to put box in brackets, if that helps make sense, then write that. In your world, it's just a box, a normal, regular kind of box. The width, obviously, is going to be important, and it's x. The length is x plus 8, height 3x minus 1. And they told us the volume is 2,100 units cubed. Determine the dimensions. So we kind of talked about one like this when we did synthetic division. So because I'm left brain, the first thing I like to do is just make a little list off to the side of what do we know and what are we trying to find. If that's not your thing, you don't have to do it. It's just the way my brain works. So the first thing I want to do is just put W equals X. W meaning width. And L equals X plus 8. L meaning length. And H equals 3x minus 1. And volume, I know, is 2,100. Again, that's not something you have to do. If you don't need to do that to understand it, don't bother. And the first step is really to create an equation. All of these are going to be based on equations. So I know this is going to be something with volume. And you just need to know the formula for volume of a box that we've talked before is length times width times height. And it doesn't matter the order. I could put width first or height first or length first because I'm multiplying them all. So step one is just creating an equation. Step two is I'm going to substitute in what I know. I know the volume is 2,100, so I'm going to put that on the left. I know the length is x plus 8. Width is x. Height is 3x minus 1. And again, the order there doesn't matter. You could put that x first if you like that better. What are we trying to find? We're trying to find x, because that will eventually give us the dimensions. These will always be calculator questions. We're never going to ask you to solve a cubic like this by hand, unless it was really, really small numbers. There's two methods for solving graphically. What are the two methods? Intercepts or intercept. Which one do you want to use? Intercepts, you want to do left-bound right, or left-hand side, right-hand side? Sounds good to me. I'm thinking you can't see that. Better? Okay, so 2,100 into y1. The right-hand side into y2. And we're going to go into Zoom like we always do, but I'm going to teach you a new Zoom that maybe you haven't seen before. So Zoom Standard is kind of our typical one, and what Zoom Standard is it sets it up like a sticky. So it's giving you from -10 to 10 in each direction. However, we know this volume is 2,100, so we know 10 and -10 isn't going to be enough. The other one we introduced you to was Zoom Trig, and Zoom Trig sets it up from -2 pi to 2 pi or -360 to 360. That's not going to work for this because there's no trig function in this equation. So I'm going to teach you about Zoom Fit, which if you scroll down and keep scrolling, you're going to hit eventually number 0, which is Zoom Fit. What Zoom Fit does is says to the calculator, hey, calculator, you figure out what you think the window should be. And 90% of the time, calculator is okay. Sometimes it will fail you, which we'll do an example like that. But most of the time, the calculator is pretty smart. So you can either hit the 0 or you can scroll down, hit Zoom Fit, and we'll see what the calculator wants it to be. And yours might be slightly different because I've got an older operating system than most of you. Did you get roughly the same graph? And all you care about is, can you see that intersection point? Go back into your y equals and just make sure none of the stat plots at the top are black. So if they are, just turn them off. Again, all we care about is can you see the intersection point? And this one we clearly can. Step 1 for showing the work is just drawing that graph. So we got kind of that squiggle through and then that straight line. What's the second thing I need to do to show work? Kind of. So how do I show that I'm about to find an intersect? We mark the point. This shows me you're about to go and calculate an intercept. You don't need to write down all those steps. That's enough to show me you didn't find the intercepts, you found the intersect. Okay, remind me, how do we find an intersect? And then 5, enter, enter, enter. X equals 7. Everybody got 7? With word problems, you just need to be careful you're going back and answering the question. So if the word problem wasn't there and this was just a graphing solution, 7 would be fine. But we need to go back and think in context. What is 7? Yes, but in terms of the situation, 7 is just the width because that's what we called x. What do we still need to find? The length and the height. So how do I find the length? Add 8, so 7 plus 8. How do I find the height? So 3 times 7 minus 1. I heard a quiet little 20. Agree? Then we need to find some units in the question. It just says units. So then I just like to sum it up saying that it's 7 units by 15 units by 20 units. Way better than last year, huh? Calculator makes things nice. Okay, let's get a method together. So what did we do in step 1? Okay, so I'm not going to put that as step 1 because this is kind of optional, right? You don't have to do that. But what did we do in the main part of the question? What's the first thing we did once we listed everything out? We wrote an equation. Did we simplify the equation? No, why not? So usually we simplify stuff. It's kind of what mathematicians like to do. Why did we not in this one? Why didn't I FOIL this out and get everything onto one side? So why did we not do that? Because we're using our calculator. So you might want to make a note for yourself, no need to simplify, do not simplify, don't have to simplify, whatever makes sense to you. If we were doing this algebraically, we would. But because we're doing it on calc, you don't need to simplify it. And what's going to happen is your brain's going to want to, and then you're wasting time on the exam that you don't need to waste. Okay, so after we wrote the equation, what did we do? Okay, so use the calculator methods. Okay. And I'll just put the S in brackets, because as we know, we have a choice, which either one you like better. You don't have to use both. What did we physically write on our paper when we used the calculator method? So we drew the graph, so draw a graph. And what did we do on the graph? Marked the points. And then we solved whichever method you wanted, intercept or intersect. So draw the graph, mark points, and solve. So that was our x equals 7, but we weren't done then. What was the very last step that we did? So I call that answer the question. So make sure you're answering whatever the question asks of you. And what's going to happen is your brain's going to want to stop at that x equal to 7 because that's all the questions we've done so far in calc. That's where we stopped. But we just have to make sure we're answering. And the very last thing we did is we made sure to get what from the question? The unit. So just make a note, don't forget the units or units in capital letters, whatever makes sense to you. Make sure you're going back and looking at the units. Okay, number 2, just read to read. Don't overthink it. Don't be scared about the big words. What's it about? Still a box. Yep, we're still talking about a box. So let's highlight the keywords. Rectangular prism. What else? X centimeters. 9 minus x. 11 minus x. What's the difference between example 1 and example 2? So they look the same, rectangular prism, a bunch of x's. What's the difference between 1 and 2? Yeah, here we're finding the volume. What did the question ask us for in number 1? The dimension. So let's see how that's going to change things. Come back, paper. Again, my brain works linearly, so I like that little list off the side. If you don't care about it, don't feel you have to do it. The problem is it didn't tell me which is which. Does it really matter? If I called the height 7 and the length 20 and the width 15, wouldn't have mattered. So you can assign whatever you want. I always go length, width, height in my head. I don't know why. It's just the order. It's not alphabetical. I don't know. So I'm going to call the length x. I'm going to call the width 9 minus x and the height 11 minus x. Again, doesn't matter. You could call the width whatever you wanted. It's still going to be the same rectangular box in the end. Still need to create a formula just like before. It's still a box, so it's still length times width times height. Difference this time is I don't have anything to put onto the left-hand side, so I'm just going to leave it as v. My length, we said, was x. Width, 9 minus x. Height, 11 minus x. So what do I do when I don't have something on the left-hand side, like the first example? Well, we're just going to graph it and see what happens. So it just means in this case I'm not going to have a y1 and a y2. Get out of there. I'm just going to put it all into y1, so whatever's on the right-hand side. So my x, 9 minus x, 11 minus x. Zoom. What do you want to pick? So if you're never sure, go with Zoom Standard first if you're never sure. It's kind of our default. Did that give us a good picture of the graph? No, we just got that little chunk kind of off to the side. So obviously we need to change it. So what I do then is try Zoom Fit. So if Zoom Standard didn't give me a good look, ask the calculator. Okay, calculator, what do you think? Better, but not great, because I need something here on the right. So if the calculator doesn't really give you a good Zoom Fit, sometimes you can ask it to Zoom Fit again. Sometimes it will try again. Sometimes you've got to manually do it. So let's try Zoom Fit again and see if the calculator will give us something better. It just gives us the same thing back, which mine did in this case. So when you need to manually change it, you go into Window. And what do we need to see more? Well, we need more of that top corner. So we're going to need to increase our y max and maybe increase our x max. So x max is 10. Let's pick something bigger. When in doubt, double it. 20. Okay, we'll see in a second what that gives us. Our y min didn't give us enough because we need it to be higher. So again, when in doubt, double it if you're not sure. So let's do 288. Go to graph, see if that'll give us a better option. Yeah, a little more cubicness going on in there, but still not great. What does that tell us? Yeah, it just means we need to play around more with the numbers. So we still need way more y max because we need some height in it. Offers? Yeah, when in doubt, double again and just add a little bit on. So I would say, well, roughly that's almost 600. Okay, so no need to be exact with this. Better. Now, what do I solve if I only have one equation? Because I can't do that intersect because I don't have a y2. Well, don't overthink this. What is the question asking for? The max volume. How did we find max and mins with quadratics? Oh, the silence. And the scared faces. We'll go to second function calc. What do you see in here? Remember, that's the menu that calculates anything on a graph. Yeah, we have a max function. So I'm going to hit number 4. What is it asking me for? So somewhere the left of where it's maxing out there. Yeah, good enough. Somewhere on the right. Hit enter. I got 3.2837013. Questions so far? What does that x represent? What does it represent in terms of this question? What did I call x? The length. Is the question asking me for the length? No, so for this question, the x value is irrelevant. It's the length of it, but it's not what the question asked me for. It's not the x value we want when we're finding max. What is it? It's the y value that you want when you're finding a max or min. So when you're finding dimensions, it's the x coordinate that's important. When you're finding a maximum or a minimum, it's the y coordinate that's important. Write that down somewhere in here. I'm going to repeat that. If you're finding dimensions, it's the x coordinate that you care about. Oh, thanks, Leah. If you're finding a max or min, it's the y coordinate. Mm-hmm. They weren't warning you for a while? They were going to die?
Yeah, but then I put in new batteries this morning. But these ones did too.
Gotcha.
Thanks.
So we could, in theory, we could state our length, which I know is 3.2, and I could state my width, and I could state my height, and I could multiply those all together to get the volume. But why would I do that when the calculator has told me the volume? What's the maximum volume? 144 point. Check the rounding instructions in the question. So the max volume is, oh, I got to draw the graph in a second. 144 point. Oh, the suspense is killing me. I heard 8 and I heard 7. 8. Totally forgot to draw the graph. Let's stick that in there. Lee, did you still have a question?
Yeah, I was just wondering what you said to write down.
Oh, if you're finding dimensions, it's the x coordinate that matters. When you're finding max or mins, it's the y.
Oh, okay.
Why did I put a little dot here? Because that's the max. So it's just roughly showing the work. I had a graph. I found the max. Here it is. Make sure we check for our units is always the last step. Centimeters cubed, because it's a volume. Show me your thumb so far. Getting it, kind of getting it, not getting it. Good, good. And if you're sideways, I'm still okay with that at this point. Read to read number 3. Now, if your read to read goes like this in your head, that's okay. A carton of sugar has dimensions, blah, blah, blah. The manufacturer wants to increase something, something, something. What should the new dimensions be? That's okay on the read to read because you're just putting the idea in your head. And what you don't understand, but subconsciously, your brain is picturing what you're reading. So it's already picturing a carton. It's thinking about it being filled up. It's adding dimensions. So read to read is just putting the idea in your head. Now we want to actually go through and pick out the most important stuff. Do I care that it's sugar? Do I care that it's a box, a carton, a bag, whatever? No, all I care about is the original dimensions. That tells me right away that it's a rectangular prism because there's 3 dimensions. Again, scientists probably care that it's sugar. The manufacturer cares as a mathematician. I don't care what's in the package. It's irrelevant to me. I just care the size of the package. We want to increase each dimension by the same amount. That's important. And we want the capacity to increase by 350 centimeters cubed. Well, capacity is a science word. What would a mathematician use for capacity? It's volume. So you might want to put that in brackets just to put that back in your head. Capacity is the same as volume. And we want something about new dimensions. The questions where you're adding something to a dimension is always going to work this way. Again, I like to start with the original dimensions. It doesn't matter what I call length, width, height. I'm just going to do them in order. So the length is 13, width is 13, height is 25. Again, if you want to put those in a different order, I don't care. They're just the 3 dimensions. And I know I want to do something to the volume, so I'm going to need him in there somewhere. But what am I doing to these is I want to crease them, and it's key that it says the same amount. So what I want to add to the length, I want to add the same volume to the width. I want to add the same volume to the height. What are we adding? We don't know. So what do we put in math when we don't know something? X. So I'm going to add X to the length. I'm going to add X to the height. And I'm going to add X to the width. And it's only because the question says the same amount that I can make those all X's. If it said different amounts, this would be a completely different question. Well, I know what I want to do to the volume is increase it by 350. Problem is what was the original volume? It wasn't given in the question, but could we find it? Sure, how could we find the original volume? It has to be just 13 times 25. So original volume is just the 3 original dimensions multiplied. So 13 times 13 times 25. Colin looks like he's got something over there. Oh, he just gave me like a look of death. Like, seriously, what was that? I didn't even ask you what you were reading today. Yeah, that was nice. 4225, did I copy that correctly? And so the new volume we want is how much? $4,000. Please don't grab your calculator. This is like mental math right here. It's really easy. We're good? This now becomes a question like question number 1. We have the volume. So I'm going to put it on the left-hand side. And again, I just realized I wrote the right-hand side in a different order. Who cares? It doesn't matter. I'm going to have a 13 plus x times a 13 plus x times a 25 plus x. If you wanted to group these 13s plus x's and just have it squared, that's fine. It's what my brain wants to do because I'm a mathematician. But the calc doesn't care, so we can just put this into the calc. Okay, so 45, 75. Oop, helps if I'm in y equals 45, 75. 13 plus x. 25 plus x. Let's try a zoom fit. See what the calculator does. Am I looking for the intersect, the intersects, the max min? What am I trying to go for here? Intersect. Why am I going for intersect? Well, because I put a y1 and a y2. Can we see the intersect? Yeah, as long as we can see it, then calculator has done well for us. So we got kind of a swoopy happening here. Ooh, that's above the x-axis. Ooh, there's my x-axis. Oh, I have them crossing on the negative side. That really bothers me. Better. I'll give you a minute or two, finish it off, actually answer the question, so make sure that you're answering what it wants. Are there rounding instructions in the question? So what's the default when the question doesn't give us rounding instructions? 3 decimal places is the default. Do we have an offer for x? 416, I heard. Now, this was actually an exam question a few years ago, and it was interesting to watch the exam panic go around the room when people hit this question. And what happened is they got 4.416 and they redid the question because it's so small that can't be right. And then they still got the same number. And then what happens is they start to stare at me during the exam, which used to creep me out, but now I'm used to it. And then they do a question a third time, and then they're just panicked. But you need to, again, use a little bit of your numeracy skills here. Are we increasing the volume by a lot or by a little bit? A little bit. That's less than 10% what we're increasing the volume. So if we're increasing the volume by a little bit, could we increase the dimensions by a lot? So this is fine. This is the correct answer. And it was just interesting to watch the exam panic float through the room. But we're not done. That's not what the question asked us for. It didn't say what are we increasing by. What did it ask for? The new dimension. So if I take 13 and add this, I'm going to get 13.416 times the 13.416 times 25.416. And I just lost myself a half mark. We need to put the units in, so centimeters times centimeters times centimeters. Volume is cubed, area is squared, dimensions are just singular. So on the exam, numbers that aren't numbers we normally get, don't assume that you're wrong. I mean, don't assume that you're right necessarily either. Sometimes there are mistakes that obviously you can make, but if you check it twice and you're getting the same answer, leave it and go on. It's not worth the stress, because what happens is your heart rate starts to increase, your blood pressure starts to increase, and then you could blow a question later on that if you stayed calm, maybe you wouldn't. Okay, so just relax. Last example, read to read. This is the stupidest question I have ever read. When are you going to use this? Never. The dimension stuff, yeah, engineers use this stuff all the time, and when people want to increase their packaging, for example, they want to keep their costs low. So 1, 2, and 3 has practical use. When is this going to happen? Never. But the government says we must do age problems, so we will do age problems. And this is the stupidest question I've ever seen. The other class said, did you make this up? I'm like, really? Do you think I would make this up? No, I did not make this up. What's important? That Leo's a jerk and just won't tell his friends his age? Hello. But somehow Sandra knows that she's younger, but yet doesn't know his age. Nonetheless, what's important in this question? One year older or 1 year old? So highlight or circle the word old, because what's going to happen is it was younger, older, and your brain's going to want to read older, but that makes a huge, huge difference. Like Hunter can't even talk. Like seriously, who made this question up? Leo says the product of their ages is 54,658 greater than the sum. I added that he's a huge math nerd, but I'm a huge math nerd and even I wouldn't do this, just saying. Can you figure out how old everyone is? So I start with Leo, obviously just going to call him L. Do we know his age? No. What do we call it when we don't know someone's age? Then I go S for Sandra. Okay, what's her relationship to Leo? 3 years younger, so is that X minus 3 or X plus 3? X minus 3. Then we have, who's the other guy? Vince. X plus 4, because he's older. And then we have H for Hunter. He's just 1. There's a who-what? Oh, it's out of focus, thank you. Better. Now it talks about the product and it talks about the sum, so what I like to do off to the side is just find the expressions for those and we'll worry about them later. What does product mean? What does that word mean mathematically? Multiply. So just multiply the 3 together. So I'm going to have an X times an X minus 3 times an X plus 4 times a 1. Do I need the 1? No, I'm just putting it there so we know we talked about Hunter even though he's a baby and can't talk. What does a sum mean? Just add it. So an X plus an X minus 3 plus an X plus 4 plus 1. Do I need the 1 there? Yes, so it definitely makes a difference with the sum, doesn't for the product. And even though we don't need to simplify, my brain just can't help it. I have to simplify this because it's so easy. So if we collect the like terms, you have an X plus an X plus an X. How many X's? 3X. And then a minus 3 plus a 4 plus a 1 plus 2. Again, this is all optional. You don't need to do any of this work. It's just the way my brain works. Now we got to come to the main equation. We got to make some kind of equation. It's something about the product and the sum. What do we know about the product? So we know we got P on one side and we got sum on the other. The problem is always where do we put that 54,000 blah, blah, blah. Is it with the product or is it with the sum? It has to be with the sum because we need this guy to be greater. So we need to add to the sum to make it a higher number. So 54,658. Just going to repeat that. If I put it on the side with P, then the sum is going to be bigger. And we know it can't be bigger, so it has to go with the sum. Well, now let's just put in those expressions. I know that the product is X times X minus 3 times X plus 4. And this is where I'm going to just ignore that 1 because we know we don't need them for the product. And the sum I have 3X plus 2. And then plus the 54,658. You don't need to simplify this. It really hurts my brain that we don't, so I'm going to just because I can't leave it, but you don't need to. But it's going to be 54,660. I just can't leave the 2 and the other number there. Just want to pause there. Any questions so far on how we set this up? So the age problems are always going to work this way. They're always going to have a bunch of people that you got to figure out their age in relation to someone. It's usually with a product and a sum. Okay, so x times x minus 3 times x plus 4. And the y2, x plus 54,660. Obviously, with a number that big, it's easier to go zoom fit and say, calculator, figure it out. How did calculator do? Not so well, because we know it's going to intersect somewhere off on this side. So what do I need to increase on the window if I need to see over here? The x max, and probably I want to increase the x min a little bit because the line's right at the top. Or sorry, the x max I meant. Max. So again, when in doubt, double it. If it's too big, not that big a deal. This one I just need a little bit. What do you want to add to make it a little bit? $60,000? Are we okay with that? And again, if it's not the right number, we go back and fix it. It's not the end of the world. So graph. It's barely there, but we can see it. If you wanted to change your x max again to get a better picture, go for it. Doesn't matter as long as you can see that intersection. What do I need to do on the graph? Just mark the point. That's showing the work, telling me you're about to calculate an intersection. Now, unless you're 5 or under, you don't count your ages in partials. I would never say I'm 40 and 11 months. Yeah, that stops when you're 5. So yes, the default is 3, but there's a couple exceptions. The exception is age, people, objects, animals, that kind of thing, or money. How would we round money if the question didn't say? 2. So I'm just going to repeat that. You might want to jot that down in red somewhere. The exceptions to our default rounding are ages. Again, we go to the nearest age or the nearest whatever. We're not going to do 47.2. People, objects, animals, that kind of thing. We wouldn't put down 42.7 raccoons. And money would be to 2 decimal places if the question doesn't say. So let's round Leo to the nearest age. 38. Now, I don't want you to think that this is what 38-year-olds sit around at parties and do. We don't. We don't take the sums and the product of our ages. We're not that lame. It's close, but it's not that lame. Are we done? Did we answer the question? What did the question ask us for? Everyone. So are we done? No, we just have Leo. So Leo we know is 38. What does that make Sandra? What does that make Vince? And Hunter? Still 1. I kind of feel like 3 adults stole a baby. But maybe it's the parents and the aunt or the uncle. I don't know. It's the weirdest question ever. They're always going to work like this. So when you get an age 1, dig this one out, follow it. Again, would this happen in real life? Never, ever, ever, ever. A little bit, yeah, yeah.